All right, here we get started on Unit 4, and we're going to be undoing everything that we did last chapter. So last chapter we were multiplying by distributing. Now this chapter we're going to be finding common factors and undoing the multiplication. So let's go through a couple vocab words here to start. So we're starting with a common factor. And if you look over here to the right, here's where I'm getting the information from. So a number or expression that is a factor of two or more numbers or polynomials. Let's make the font bigger, bolder, and I'm going to choose a different color here this time. Okay, and then we're on greatest common factor. The greatest number or expression that is a factor of two or more numbers, or it is often referred to as a GCF. So you may remember this from middle school, finding a GCF or greatest common factor. That's what this chapter is going to start off with. All right, the grouping method. This is a factoring method that begins with separating the terms of a polynomial into groups. The next step is to factor out the GCF of each group, and if the remaining polynomial factors are the same, you can use the distributive property to reverse and factor them out. All right, so now let's summarize and organize the information with some fill in the blanks. So use the grouping method to factor a polynomial is like using the distributive property in reverse. So let's see what we mean. Using the distributive property in reverse divides a factor out of a product. So here's my variables. This A is multiplying times B times C. And then here, we're going to go in reverse. We're going to take out the A and leaving us with B plus C. Here, we notice that a 6x multiplies by x and 2, giving us this polynomial. Now we're going to be factoring out the 6x, leaving us with the binomial x2. So it's the undoing of what we did last chapter. So identifying a common factor, we usually want you to think if every term divides evenly by something, then that's your common factor. So here, for example, what divides evenly into everything is a 2, so your common factor is a 2. We use the distributive property in reverse to factor out, and so if I take out the 2 here, the 2 here, and the 2 here, I can see that that will leave me a 2 in front. Let's go use the equation editor on this one because we need a squared. So the 2 in front, and then x squared plus 2x plus 5 is left. After you pulled a 2 out, this is left. All right, some polynomials have more than one common factor. When this happens, you should factor out the greatest common factor, or the GCF. The greatest common factor of a polynomial can be a number, or a variable, or an expression. So for example, if I look at this polynomial of 3x plus 6, I think what divides evenly into 3 and 6, and my GCF, or greatest common factor, is 3. So once we factor out a 3, I would be left with what could I multiply in order to get that original expression? It leaves me x plus 2. Here, the greatest common factor is an actual variable. Here, there's an extra x in each of the terms. So if I factor out that x, it's going to leave me with x squared minus x plus 1. And finally, you can have an entire expression that GCFs out. So here there's an extra 2 that divides into everything, and there's an extra x. So my GCF here is 2x. And so we're going to go factor out that 2x. And what would be left inside if I take out a 2x would just be x minus 5. So the main idea, the grouping method can still be used when only some of the polynomial terms share a common factor. Factor x squared from the first 2 terms, and then factor 3 from the second 2 terms. So for example, here an x squared can factor out, leaving me 2x plus 5. And then factoring a 3 out of the other 2 terms, a 3 can factor out, leaving me 2x plus 5. So factoring out the greatest common factor from each group. So if here there's an x squared times 2x plus 5, And if here there's a 3 times 2x plus 5, you'll notice the 2x plus 5 is in common. So we're going to factor out this time the 2x plus 5 as our common factor. And then that leaves us x squared plus 3 in the other. The grouping method and FOIL are inverse operations of each other. So you can use FOIL to check the factoring that you did. You can double check by multiplying backwards. All right, so factoring with grouping and then check with the FOIL method. So factor a 7x from the first two terms. So we're taking out a 7x, and that's going to leave us, if we divide out a 7x here, it leaves us x squared. If we divide out a 7x here, it leaves us 3. The sign in the middle stays the same. Factor a 2 out from the last two terms. So taking out a 2 here will leave x squared. Taking out a 2 here will leave 3. And then we're noticing that the factor that's in common is the x squared plus 3. So if we go ahead and take out the x squared plus 3 as the common factor, then what remains is this 7x from the first grouping and the 2 from the second grouping. Now over here is checking with FOIL. So let's double check this. I'm going to copy and paste it over. And then we're checking it with FOIL. So that means if I multiply 7x times x squared and 7x times 3, I would get 7x to the third plus 21x. So if I look back to what I originally started with, that works. Same thing here. But if I double check this by foiling, it's going to be 2 times x squared plus 2 times 3, and that gives me 2x squared plus 6. And I look back at the original that I started with, and that's what I started with. Finally, if I FOIL this, here times here, outer, inner, last. And then I multiply these all the way out. I look up at the top, 7x cubed plus 21x plus 2x squared plus 6, and I'm left with what I started with. So foiling the entire thing here, multiplying out each part that we just got, this is our way to double check our answer.